So today we will sell electric bulb. So in your book, I think, so we'll have a look on your book also. So we will now today start with electro, that is magnetism, magnetic effect, and then it'll end. The lesson is gonna end. So we will complete it. We won't complete it today, maybe, but we will cover. So bulbs. So incandescent bulb. So we all know this kind of bulbs in the homes. This is a very basic bulb that most of our homes will have this kind of bulb. Yes. In the starting, we have these kind of bulbs.
Yes, ma'am.
So these are called as incandescent bulbs. We will say it will be orange in color. It will glow orange. So incandescent bulbs produce light by heating a filament until it glows. So basically, how it's happening, they heat the filament. So electricity will, with the help of electricity, so this is coming under heat effect of electric current. So with the help of electric
Ma'am,
current,
the like filament is made up of like is it made up of like a
tungsten.
heat conductor or a
Tungsten.
electric? Ma'am,
Yeah,
tungsten that is like a heat conductor or like
obviously, no. So if you are not making it with the help of heat conductor, how it will get heated? No, it's just logically it's like that.
Conductor of light also, which can allow light.
Nobody is allowing the light there when it's actually the mechanism of the glass, how it is producing. When it started to burn, it gets reflected. Like you have the glass, it get like glass is a transparent medium, no? So you
ma'am,
get the light.
is it like a conductor of electricity also?
Obviously, no? Without electricity, it is a conductor of electricity. All metal conducts electricity, almost all metals. Okay?
Okay, ma'am.
So a significant portion of the electricity consumed by incandescent bulb is converted to heat rather than light, leading to energy wastage. So what is there coming to tell? A significant portion of, so they are conducting it to light also, and light will be somewhat visible, and you have a transparent medium, so that will be more good. So it will be because of the transparent medium of the glass, you are getting some more good light also. A significant portion of the electricity is consumed by incandescent bulb is converted to heat rather than light. Obviously, this is a very good observation. I think everybody would be knowing. So when you go and touch that bulb after switching off, you will feel very hot. That will be very, very hot. So because they produce heat also. Some amount of, so it is meaning is that the amount of energy is not fully utilized only for producing the light. For heat also, it is wasting a lot of energy. Okay, so efficiency. So when you see efficiency, obviously you all will know. Nowadays we are getting more advanced bulbs. These are very basic bulbs in a lot like history times. So these bulbs are less energy efficient because they use more electricity to produce the same amount of light compared to other technologies. So they use a lot of electricity basically, and they are wasting the electricity in producing a lot of heat also. So they basically are not advisable. So if you see the structure of electric bulb, so they have a glass chamber, so contact wires and glass mounted, and they have a cap and electrical contact gas they have, and tungsten filament. Yes.
Ma-
Ma'am,
Ma'am,
what gas is filled inside the bulb?
argon.
Like, yeah.
Ma'am,
So
it's like argon gas.
correct. It's correct. Yeah.
Inert gases.
Ma'am, it's air, right? The
Yeah.
chemical formula, air.
Yes.
Inert gases.
Ma'am,
Yeah,
but like I have a doubt, like why the air gas is present inside the bulb?
So you just guess like why air gas is there. Just guess.
Ma'am, I'll
Just
just guess.
go with the.
I'll just guess that it is because like the bulb will like be like the bulb's like the outer part is made up of glass. So I think that to prevent it from like blasting or like not blasting, like if it fell down slow, it will like it keeps the glass a bit hard
Okay.
compared to normal gases. Because
Okay.
I just learned in grade
Okay.
6, but I
Fine. The
forgot.
reason is, it's okay. The reason is, so you all, I don't know, like you have the presence of oxygen everywhere, no? We have the presence
Yes.
of oxygen everywhere. So you will be, I don't know whether you know this term like corrosion. Corrosion, right? So corrosion means like it will be eradicate, like that will lose its texture. So when you use, for example, you are using your slipper for a long time, your slipper sole will be like somewhat, that will not be like the new one. You can realize that when you use eraser, you erase the things, your eraser shortens, right? So that is like they lose their lifetime. Like that, corrosion is something like they, because of this tungsten filament, like the bulb is glowing. The tungsten, that is a metal, no? So the oxygen is present. So when they will react with the oxygen, when they are reacting with the oxygen, they will eventually lead to corrosion. And they will like when you take steel or iron, they will have this rust, like that, some kind of phenomenon. So they will have corrosion, and that will reduce the lifetime of the bulb. Because of that, argon gas is used there. So inert gases. So what is the main usage of inert gases? Like they doesn't react. They block the reaction between the tungsten and the oxygen gas, so that it also stops the filament from burning away in the presence of oxygen. Like hence it is increasing the bulb's life also. Yes, it's like have many advantages. One of the important advantages, it is preventing the tungsten from getting corrosion because of the oxygen presence. And yeah, one more
Ma'am,
thing is like they increase the bulb's
Ma'am?
life. Yeah.
ma'am, when I was making a circuit last year, but then somehow my tungsten burned.
Sometimes it will happen. Sometimes it will happen when it is very old, or like sometimes because of some mistakes or something. Sometimes it may happen.
I'm like, if the fuse is gone, like it got burned, then like the filament is gonna blast or like.
It won't blast. Why it will blast?
No, I'm like, sorry, I'm not the fuse, like the resistor. If we won't keep fuse and if we keep resistor,
Mm-hmm.
and if the resistor is gone, so like, will it like affect the whole bulb or only the filament?
I think it will affect the whole bulb also, because you have the force. Something called force is also there. Force is present in every body. Every body exerts some kind of force. So
Yes.
because of the force, it may get exploded, and already heat will be present. So heat will also add more fire to the thing. So it may blast. 90% it will blast. I think so.
Ma'am, like, can bulbs cause like fire and anything like that? No,
I
right?
think so. No, not so much. Like most of the cases, they don't do that.
Okay.
Now going to fluorescent tubes and compact fluorescent lamps. So CFLs. It's a very, very famous, between they are very famous. CFL bulbs are very, very famous. So they have quite good advancements than the normal bulbs. Compared to that bulb, they uses less energy and they give more efficiency. So we'll see. Description. Fluorescent tubes and CFLs use a different technology that involves exciting mercury vapor to produce UV light, which causes a phosphorescent coating inside the tube to glow. So this is a mechanism you have to understand. So this is a chemical reaction. The scientists or maybe the inventors or discovering people, they have understood this concept. They have utilized that concept of UV and they implemented in this. It's very good idea actually. So fluorescent tubes and CFLs use a different technology. So here the technology is very simple. They are made up of tungsten and the electricity is going inside. They burn and they give the light energy and heat energy. But here the technology is different. Mercury vapor to there we use argon gas. So here they are using mercury's vapor to produce UV light. So they have to produce the UV light. So for producing the UV light, they are using mercury vapor, which then causes a phosphorescent coating inside the tube. So because of the reaction, it is having a phosphorescent coating. So causes it's all a chemical reaction. So mercury vapor is there. Mercury vapor is giving you UV light. So it is there. If you keep the mercury vapor, it is giving you UV light. And because of the UV light is like something, or I think it may be all happening here. So UV light is there. And because of the presence of UV light, phosphorescent coating will be automatically caused inside the coatings, like tubes of the bulbs. Phosphorescent in the sense, like phosphorescent itself, like it's like a lighting mechanism. Like it will glow. The glow, that is the, uh, that is phosphorescence, one of the properties, you can say like that. It will glow. So energy efficiency. You see, energy efficiency, these are more electricity efficient than incandescent bulbs. So obviously, right? So you can easily say in tungsten bulbs, everything comes from electricity only. Then only tungsten starts to glow. But here they are using some chemical reactions to already start the bulb, and electricity will add more good, like more it like a extra support to maximize the light capacity. Okay, so energy, so here chemical reaction is also involving, and then electricity plus electricity is also involving. So obviously this will give more results and less electricity consumption. So meaning they consume less electricity to produce same amount of light. Okay, so environmental concern. So when it comes to environmental concern, fluorescent tubes and CFL contain mercury vapor, which is toxic. Okay. So damaged or spent tubes need to be disposed of safely to avoid the environmental contamination. So it's just like they're telling you, if you have any CFL bulbs in your home and it's not working, you have to throw them and you have to dispose them in a correct way, because mercury vapor is good, not good for environment contamination. Okay, it gives environmental contamination.
Ma'am, I have
Yeah.
a doubt.
Okay.
I'm like in
Mhm.
I'm like in some different bulbs. There are like
Okay.
one more kind of bulb there. Like it looks the same. Like we call it like LED. Like it will be connected. I have it my home. Like it will be connected
Uh-huh.
with my phone. My
Yeah.
phone, and whatever color we want, whatever song we want, we can add there.
Yes, ma'am. Like
So how does
it
it
is
like work?
Advanced version of CFL. The first version is electric bulb, that is incandescent, and then CFL came, and I think I have not included that in your PPT. So we'll see here. I think it's given here CFL. It's filament incandescent bulb. See here. Yeah, CFLs. This para. LED bulb consumes. So LED, you are talking about LED. So the fluorescent tube lights, compact fluorescent lamps, CFLs are better electricity efficient. Nowadays, the use of a light emitting diode, so they call it as LED bulbs, is electricity is increasing. For producing a given intensity of light, LED bulbs consume less electricity as compared to incandescent bulbs or fluorescent. They are more advanced version of CFLs also.
ma'am.
Thus,
Like
LED,
they also
yeah.
use these mercury vapors.
No, they don't use mercury vapors, I think so. The mechanism is entirely different for LEDs, actually. So for that, I'll make a PPT separately and tell you, because that is a lot of things to get understand. Have to understand a lot of things. That's out of your age. So process of how the LED works. The LEDs nowadays they're in TVs also, computers also. So LED screens are
Yes.
there. So the same mechanism, LED bulbs are also there. So it's a big mechanism to understand. It's a complex mechanism to understand how they are utilizing that. But LED is the most first version. Now all are using LED bulbs. Obviously, they consume less electricity when compared to other two. Okay, so it is advised to use electrical appliances and gadgets which are electrically efficient. Bureau of Standards, Indian standard, that is ISI. So these are some of the things. And fluorescent tubes in CFL contain mercury vapor, as I told you. Yes. So going back here, so what is a compact fluorescent light bulb? So you have seen this like electrodes is given, mercury argon gas is there, and phosphorus coating will be there. So when the mercury argon gas is emitted, it will react, it will produce UV light and it will react with the phosphor coating and it will glow. Glass tube, electrodes, and base, ballast. These are some of the
Now what
parts
is
of the.
ballast?
You can see that. So you can see here. This is ballast.
Okay, ma'am. Like
This area.
the all these mercury vapor like are present in ballast.
You cannot say like that. Maybe when the process starts, it will start emitting. It will start slowly emitting, and you can see here mercury gas is present here. They have given.
Okay, ma'am.
Yeah.
Ma'am, like based on like my knowledge, like I have heard like something like that if you need to make something, you need to like learn like how to do it, and you need to like I don't know how to say, like you need to get like some you need to get ideas. Like I'm asking like for these bulbs, like for this kind of like these LED bulbs, like on which thought process did they like invented it?
Thought
Like
process,
on which
first you need to have a motivation. So first we need light. So because of that, I've told that inventor of bulb in the very first day of class. I hope you all remember it.
Ma'am,
So the
ma'am,
inventor of bulb, light bulb, yeah.
ma'am, how lamps are invented? Like, do they also have bulb in it?
Obviously, no. Same mechanism. Just outside it looks different, but same mechanism, nothing different.
Okay, ma'am, like
Just from
so
outside they look different.
a bulb which is covered with like a cloth, like a bag type.
Baga.
No, I'm like what we call,
Like that olden kind of bulbs. Olden days.
yes, ma'am, olden.
Chandle, I mean, like it'll be like that is not a that is you, Rishit, that is not a bulb. It is just a lamp. It's lamp.
Okay, ma'am. Like so,
And nowadays it's bulbs are there and same mechanism. Mechanism doesn't differ in anything. If it is a
okay,
bulb
ma'am.
with same mechanism, uses electricity and glow, tungsten filament basically. Or
Okay,
else
ma'am.
nowadays it is CFL or fluorescent. So the mechanism doesn't differ, but olden days they used normal lamps that we use for temples, no, normal lamps they'll keep inside and
Yes.
they will use that only. So now we are entering into magnetism. So because of the electric current we are having heat
ma'am,
effect and
like before going
yeah,
to magnetism, I want to ask the doubt like watches also, like some normal kind of watch, not smartwatch, like normal kind of watches. Like in my watch, like if I there's one light button. If I click that button, light turns on.
yeah,
Like different colors light. So like
yeah,
what's this like how light is produced there?
same mechanism. Like, see, the mechanism of light is now getting advanced. So watches having light on the watches is all not very early. It's very, very recent. No, after like invention of CFL itself, they have, I think they have bought these technologies in the smart watches. Sorry, not smart watches, watches and all. Same mechanism. The bulbs amount of the light coming out and the bulb size will be very small. That is the thing.
Okay.
And when it comes to color changing, I think there will be different bulbs, or there may be like a single bulb and they will be using some chemical reactions to change the color. Mostly chemical reactions. That will be there actually.
Okay, ma'am.
Yeah. So we are going into magnetic effect. So as I told you, we have two things. That is, one is heating effect and one is magnetic effect. They have not, in your book, they have not given any problems on magnetic effect. And I also don't want to go into magnetic effect problems because it's not your standards. So we don't want to enter into problematic part in magnets. So it will be full theory. But you need to understand the concepts. So conduct this experiment step by step. So just we will just go through the experiment. A discarded matchbox. Use the cardboard tray inside it. Okay, you know what is a discarded matchbox, right? A matchbox without the matchsticks. Basically, discarded matchbox. Yes.
Yes, ma'am.
Yeah.
Yes.
Insulated copper wire and small compass needle, electric cell, that's small battery, switch and bar magnet. You need these things. First step, prepare the cardboard tray. So take the cardboard tray from inside the discarded matchbox. So I hope you can imagine the things when I read. Yes. So the matchbox will be like this, and inside the tray will be there. You have to take out that cardboard tray, and then you keep it. Wrap the wire. Wrap the insulated copper wire around the cardboard tray several times. You have to wrap the insulated copper wire. Like I think they're telling to do like this. Creating a coil. So coil is something. This structure is called coil. So I have told you correctly. So this is a matchbox tray. So you have to coil it like this. Make sure you leave enough wire at both ends. So wire should be left because to connect with the battery, obviously. Yes.
Yeah.
So to connect to the electric cell and the switch. Place the compass. So place the small compass needle inside the cardboard tray in the middle of the coil. So you have to, this is the cardboard tray, and inside that you will already place, I think that is how they are trying to tell. Place the small compass needle inside the cardboard tray. You have to place it inside the cardboard tray in the middle of the coil. Coil will be like this, and the middle of the coil, you will be placing your compass here. Connect the circuit. You know, you have to connect one end with the battery and one end with the switch. Connect the free end switch to the wire to an electric battery through a switch as shown in the diagram below. See the diagram there? I'll show you in the book. Your book is having. So when you conduct the experiment, describe. So first we're going to the before going to the result, can you guess what will happen?
Ma'am, like I have drew one diagram. Can I show you?
Yeah.
Okay, ma'am. Just a minute, ma'am. Ma'am, like this is my diagram, like of like the electromagnet. So, like I think that when electricity passes through like this, or okay, like this we take, so it will like it will be, this the things will be of metal, I think, because I studied in grade like my mom told that most of the materials will be metals. So now if this wire is connected like this and this and like this, so that means that they are producing like some current effect and they are getting charged. So the metal is getting magnet, like it's getting charged by by electricity, it's getting magnetic effect. And then when they keep it some like another steel metal or magnet, then it gets attracted with a strong force of energy. And like if we keep it for too long,
Yeah.
like if we keep a real magnet here and we'll wrap it with this, so that means that this magnet can be a permanent magnet.
Yeah. Yes.
Yes.
Correct. So basically what you will observe? You will observe the magnetic effect will be there. So you cannot question, ma'am, how magnetic effects are produced. That's nature. And I think you have proofs on internet like how the magnetic effect is being produced because of electricity. Have proofs for that. Simple thing. When you go and for example, just think about this situation. You go and press some switch box. If you're getting shocked, when you are in the shock, your body will not work. I mean, you cannot take the hands out from the shock. Have you ever
Yes,
like experienced that?
ma'am, I
My
didn't, but
mother
like
did when she was
my
in college.
but my like my one
Somebody,
of the friend experienced this, so he told.
yeah, some of them from outside they have to come and help. They will be knowing that they are under shock, but they can't take out. Like they
Yes,
will not
ma'am.
be permitted to take out.
Ma'am, I experienced that.
Yeah, yeah. So somebody else should come and help from outside. So basically, your body itself is you have metals, right? You have skeletons, bones, you have minerals, you have water also. So all are good conductors of electricity. So you have magnet, and you know this also when somebody else comes, touches you, they will also get electric current. No, so it's not magnetism. That you cannot say that as magnetism because electric current passes from one body to other body. But I'm telling you because like magnetic effect will be there when you get electric shock that will be applied on your human body also. Yes.
When
Yeah.
we get electric shock, you told that like somebody needs to like push us out from that like electric switch or something.
Yes. Yeah.
But the like the electricity passes from one body to other one, no, ma'am. So
Yeah.
if it touches, he also might get shocked.
Yeah. So we have to use you have to use insulators. Like you have to take the wooden rod and you have to beat them. That are some of the things. You have to use the rubber slipper and you can touch them so that you won't get electric shock
Ma'am, we
and you
can
can
Ma'am,
save
like
close
your
the
body.
main switch. That
You
main
can close the
switch.
main switch. That is one of the idea. Good idea.
Ma'am, like I have a doubt, like
ma'am, like if we are in like if we got current shock, can we speak?
Try speaking. I don't know. I
Okay.
don't know. I don't know. I think so. You cannot. Your mind will not work that time. You will just experience the shock.
Yes.
That's all. You won't.
I'm not sure
Yeah.
is that shock, but like it was someone's marriage, so we were playing, and by mistakenly we touched that light, like which is placed to the walls, like decorating lights.
Okay.
Like all of my cousins, they were not moving; they were like statue. So
Yeah.
I just went and touched him, and like I got some like different vibration in my body, like.
Yeah.
So is
So
that
that
current
is what
shock?
I'm trying to say. Your brain will not work when you're under shock. So that is
Yes.
how exactly it happens. So it's basically, as Siddhant explained, it's magnetic effect.
Can a human being even survive a shock?
You can survive a shock. That's not a big thing, but
I'm
it
like,
is
Ma'am,
what if
ma'am,
we
but
touch a
when the shock is like,
so
transformer
high,
like
then you cannot survive.
voltage?
When it is a big thing like when it is big thing, then you cannot survive.
I'm like,
Like
what's the
the
maximum voltage like which a human can bear?
you go and search. I don't have idea. I think some volts maximum human can will search in Google. You want maximum volts human body can tolerate. Yes. So it's 100 to 250. It has up. Just if you supply 42 volts, death is occurring, it seems. You will be dead only with the help of 42 volts.
Okay.
ma'am,
Yes?
like I have a doubt. Ma'am, like for my
Yeah.
as I explained, like I have a doubt in my explanation only. Like as I explained, like
Mm-hmm.
the wire will like the wire will charge the metal and convert it to magnetic. So that wire like it will it be covered with like with an insulator, or it will be like covered like just a wire, because it will get charged, right?
Don't get,
It will not be
yeah, to be
connected to
just,
the end.
don't get covered. Yeah. No, it will
Ma'am,
not be
but what if we
insulated.
touch that wire?
It will be just, you should
If
not
we
touch
touch
that
it,
wire
then
when it is circuit is if you touch, you may get shock, but that shock will not affect you because that will be very
Ma'am,
minimum
like that
amount of
is
shock that you
too
will
small battery.
have the effect.
9 volts
Yeah,
battery.
too small
Something.
battery. Yes. So the
ma'am,
magnet
like
will not
one
have any
time
effect on.
I was like I took one wire, like I took one wire that was not even like insulated, like it was totally a wire, and I connected the battery, and I holded the wire and the battery together. I don't know what kind of shock I got. I like
Okay.
both the ends I completed with the circuit to test it. I don't know what kind of shock I got. For 2 seconds or 3 seconds, I got a shock completely.
You will get a shock, minute shock like that. I don't know whether you all did this or not. You have a watch battery, a watch
Yes, ma'am.
battery you take and you
But
put the tip of your tongue.
Buttons.
In the tip of your tongue,
Yes,
you
ma'am. I
get a shock.
tried so many times.
Yes, you will get a shock. Take the normal battery, remote batteries you keep in the tip of your tongue, you will get a shock.
Ma'am, like a different kind of taste will come.
Yes, that is actually shock. It's not taste, it's shock. But we
ma'am means like we
very
are tasting
small,
the shock.
minute amount. Yeah, it's a small amount of shock. So it's not like just taste for you. It's not even a
Now
shock.
what happens like if we connect two wires which are connected to the battery, like red wire and black wire,
Okay.
and they are connected to the battery at one end,
Okay.
and if we connect the both ends to each other, like red wire sent to black wire and vice versa.
Oh, you're asking me like this is a battery and you're connecting the wires together like this.
Yes, ma'am. Yes, ma'am.
So I think maybe the charges just flow will be there. Nothing will not happen. Just it will come here, it goes here. It's like just a cycle. It will happen. I don't think so. Anything much will happen.
Okay, ma'am. So
Ma'am,
like
like the battery would be
normal
like.
circuit, but like without a bulb or switch.
Yes. Yes. No consumption will be there. Consumption will be zero because no appliances are connected on the circuit, but circuit will be running. Circuit will be active.
Ma'am, like for a normal battery circuit, we don't need resistor or fuse, right?
Yeah,
Because it cannot like do prevent, like it cannot give more electricity.
yeah, correct.
Yes.
You're right. And now we'll go to the results. When you conduct the experiment described, you should observe the following results. So initial observation is switching off. So initially you are switching off. Compass needle points in the usual direction, typically towards Earth's magnetic north. This is because the compass needle aligns with the Earth's magnetic field. So when normally I don't know whether you have seen that magnetic compass. Normally it will show where the Earth north field is there. There only it will be there. Default. By default, it will show north. Okay, like that it has been designed. So the first thing is like when you switch off, no current is passing, no electric magnetic field is there. So just normal alignment will be seen in the compass. And bringing the bar magnet near the compass, you're bringing a bar magnet near the compass. As you bring the bar magnet, the needle will move and point towards the magnet's north pole or south pole. Before that, it was Earth's north pole. But when you bring the bar magnet near, it is magnet's north pole or south pole, depending on which pole you bring closer. This demonstrates the influence of an external magnetic field on the compass needle. Yes. So why it is changing? Because some external magnetic field is there. Apart from Earth, external magnetic field is there. That's why it is showing. So switch on. When you switch on, now the current comes in the picture. Before it was just a bar magnet and normal Earth magnet. Now current is coming to the picture. So when you turn the switch on, electric current flows through the wire coil wrapped around the cardboard tray. So the compass needle will move from its original position and align with the new magnetic field created by electric current flowing through the wire coil. So the current that is flowing in the coil, we don't know in which direction is that. So it will be based on that, the compass will be showing which direction the current is flowing. For example, if the current is flowing in this direction or in this direction, it will show based on north or south. Yes, and this shows the electric current creates a magnetic field around the wire. So this is an experiment that is proving that you have a magnetic field. When current is there, you have a magnetic field also produced. So conclusion of this
I have a
experiment.
doubt.
Yeah.
On magnets only, just allow me to like open my camera. Just a minute. So my doubt here is like if we take one magnet here like north and south, and then one more magnet that is like a new formed magnet, like a newly formed bar magnet. Now it was given in my Olympiad book also. Like now find the north direction and find the south direction in this magnet with the help of this magnet. So now I can easily find which is like if I take suppose I'll just attract if this pole attracts with this pole, then this both are north and north. So
Wait, come again.
I'm like if this pole
Okay. This pole.
is attracting this pole, then this pole will be south.
Yeah, that pole is south. Yeah.
But the question is how will we know exactly?
How will we know exactly? Mean that is a proof, no? Opposite poles attract each other. So you have already a known magnet. So you have the names like north and south. So you bring the new magnet. If the north position is there, it is going away. Repelling means that is obviously the north of the new magnet. And if the new magnet is, if the north side of the old magnet is attracting the side of that unknown side of the magnet, it means it is south. It is a theory. Proof is there for that theory. So you have to believe it.
Ma'am,
Okay.
ma'am, how do those U-shaped magnets work?
Usual magnets, like
No, U-shaped magnets.
horseshoe. It's called as horseshoe. Same,
The horseshoe
nothing
magnet.
different. Bar is like this. Horseshoe is like this. That is the only difference. Same
Ma'am,
magnetic
but
effect.
the north and south are both at the same side.
No, they are not same side. This side is north and this side is south.
Ma'am, so like when I was like first time I saw the horseshoe magnet, I thought like
Mhm.
it was so powerful. Like in cartoons they'll show, na, ma'am, if we hold a horseshoe
Yeah.
magnet, everything comes to us.
No, that's just a cartoon.
Yeah, ma'am, that was just used for cartoons.
Yeah, that's not true actually. So yes, so interact direction of the field. Okay, confirming. So we will just go to the conclusion and end. This experiment confirms the magnetic effect of electric current. So magnetic field creation. So obviously there will be a field creation. Then only you will have the magnetic effect. So when you want to feel the electricity, electric field should be created. Field in the sense, so this is the field. If I tell the electric current is going in this way, I will say this as a field, electric field. Just name, that's all. So because of electric current, I am getting magnetic force in this area. So I will tell this, I will call this as a magnetic field. That's all. Field lines of magnet, group of field lines are called as electric field or magnetic field. That's all. So magnetic field creation, an electric current flowing through a wire produces a magnetic field around the wire. Direction of the magnetic field, direction of the magnetic obviously depend on the direction of current. So direction of current, you have to remember, this directly proportional to direction of magnet. So when you change the direction of current, magnet current also changes accordingly. Yes. Interaction with compass, the magnetic field created by the electric current interacts with the compass needle, causing it to move. So compass, the work of the compass needle is to show the direction of the magnet. So that work is done by the compass. This simple experiment effectively demonstrates how electric current can create a magnetic field and how this field can influence magnetic compass. Yes. So the homework for you, the next class is, you will find and come what are the use. So we saw for because of heating effect, we have saw iron box, and we did saw those things. Did I teach you those things like applications of Joule's law? We didn't teach. I didn't teach.
Ma'am,
We
I
didn't
don't
see the application of Joule's law, right?
know.
So nothing. Just I'll tell you. It's just like a story. So what are the applications of heating effect? Can you people name it? Name a few.
Ma'am, like iron box.
Iron box. Yeah.
Ma'am, can you repeat the question?
So where we are getting the heat, like where the heat is very important to us, we are using the heat in various aspects of our life. So how it is coming from electricity. For example, we are getting light energy from bulbs. So electric energy is basically converted to light energy and heat energy also. But when you take somebody told iron box, so iron box is basically we require the hotness. So electricity is converted to heat only. So like that, I'm asking what are the appliances like that? It is
Ma'am,
converted
heater.
to heat energy.
Heater.
Water
Ma'am,
heater.
Ma'am, heater.
Ma'am,
Yeah, very good. Heater.
ma'am,
Microwave.
electric cooker.
Kettles,
Oven.
ovens,
Ovens. Okay.
Ma'am,
Oven.
microwave.
Ma'am, straightener.
ma'am, iron.
What? Iron box.
Yes, ma'am.
Yeah, iron
Ma'am.
box. Yeah.
Ma'am, even hair straightener.
What?
Hair straightener, ma'am.
Hair straightener. Very good. Hair straightener. Hair straightener is gonna create the heat energy, heatness, electricity, heat energy. Yes. Then anything else?
Indecent. Ma'am, is that
Toaster.
hair dryer?
What? Hair
Ma'am,
dryer.
toaster.
Ma'am.
Yeah. Advika.
Ma'am, toaster.
Toaster. Yes. Bread toaster. Yes.
Ma'am, light bulb.
Induction stove. Electric
Ma'am,
gas
light
stove.
bulb.
Induction stove. Yeah, night bulbs. Right? Electric gas stove, you people know, right? Like they are called as induction stove.
Yes.
Ma'am, laptop. Computer.
Laptop. No, laptop is not. See, one more important thing I wanted to say. Like when it comes to heat energy, wherever you see light is there, electricity is there, heat will be there. Okay, it's part and parcel of electricity is heat energy. It will be dissipated. Dissipated means some amount of heat will always be there in every appliances that is working electrically. Okay, for example, Hamza told laptop. So if you touch laptop, you can feel the heatness, hot layer will be there.
Ma'am,
Because
mobile charger.
it doesn't mean that, yeah, mobile charger. So wherever electricity is there, you will feel the heat. That is mandatory. But my question is,
Ma'am, the microwave
yeah, oven.
on electricity, right?
Yeah. So my question is, wherever you see the electric current, that is fully converted to heat energy only. For example, dryers, electric heat, water heaters. So there, if you see, there is no other energy is released, only heat is there. But when you take laptops, light energy, sound energy, and heat energy is there. Am I right?
Yes, ma'am.
Yes.
So yeah. So where the electricity is only useful for producing heat, for example, you will say heaters, dryers, electric gas stoves, so iron box. These in these appliances only heat is coming. No other energy is released. Yes.
Yes,
Uh,
ma'am.
electricity, and if electricity is there, heat is there.
Yeah.
So, but these light and sound are like as per the device.
Yes. So yes. So my
Like the
question
bulb,
was like, yeah, yeah.
electric bulb has tungsten, so it has light.
Light energy also. So those people
Yes.
doesn't come under, like, those are not designed to produce heat. They are designed to produce light. So
Light,
laptops are not designed to produce heat. They are designed to give light energy and some other
sound.
function, technical
Yes.
functions. Sound energy. So when a primary uses something else and not heat, but the heat will be dissipated, heat will be coming. Okay, you cannot control that. But primary usage of that will not have any heat energy released. Should not be released. But when you take iron box, the primary usage of iron box is to release
Heat.
heat. Yes. Correct. So that is the difference. Got
Okay.
it? So your homework will be, you will go to home after this class, you will find me the help, like how we are seeing the heat energy, heat effect is helping us in various places, like that, how magnetic effect is helping. So these both effects are created with the help of electricity.
Electricity.
So we discussed about heat now. That's all. That is a Joule's heating effect, applications of heating effect. Now, what are the applications of magnetic effect? Think and come in the next class. Yes?
Yes, ma'am.
Okay, then
Ma'am,
bye.
I didn't understand. Ma'am, I didn't understand.
Now we were discussing about the applications of heat energy, right?
Yes, ma'am.
Like that, I need some list of things that we use in our day-to-day life with the help of magnets. The applications of magnetic effect due to current.
Okay, ma'am.
Due to current. Yes?
Okay,
Ma'am,
ma'am.
and I have a doubt. Like these days in internet, like YouTube, if we search like science experiments, it shows like we need to connect 4 spoons, like making a square. And if we put 4 batteries like at the
Mm-hmm.
each corner, and if we put a coin in the middle, the coin rotates.
I think because of the effect of magnetism. Magnetism only, I think so.
Ma'am, one more thing, like,
Yes, then please do the homework. Yeah.
ma'am, one more thing, like, for my science fair, ma'am,
Yeah,
I'm
tell
not
me.
even getting one idea, ma'am. Like, my submission date is June 19th, and today is June, like, it's tomorrow is June 5th. I didn't even decide what
You
will I
text
do.
me the WhatsApp. No, text me the WhatsApp. I'll search and
Okay,
send
ma'am.
you something. Yeah.
Okay, ma'am. Okay, ma'am. Bye.